Yeah, I mean, I guess we're talking about your paper, Big Little Lies, a compendium and simulation of p-hacking strategies. Maybe just like as an easy way in, kind of how did you start working on this project? Yeah, it seems also to me that you did, from what I can tell, you did your bachelor's and master's in Munich and now in Amsterdam, but this project is with someone from Munich. So I'm curious whether that like started before your PhD or how that kind of got going.
So the project actually started during my PhD, but it has been a work in progress since a couple of years already. So Felix Schimbrot is my the co-supervisor of my PhD, so I'm still working together with him a lot. And so it started out with, we wanted to do something some meta science study, and we wanted to look at maybe something like p-hacking and meta-analyses. And so I started looking at the literature, and I started looking at the p-hacking literature and what people had written about p-hacking. And I started realizing that there's actually there's little clarity about the definition of p-hacking, because everyone basically in their articles comes up with their own definition of p-hacking, which is usually a definition by example. So p-hacking is when people try to get a significant result using methods such as and then they name a couple of examples for p-hacking, such as deleting outliers or using multiple dependent variables and reporting only one of them, or using different imputation methods, for example. And the issue was that everyone had a different collection of strategies that they named. So there wasn't a lot of unity in those p-hacking definitions. And this is basically where this project took its start, that we started just doing a big literature review, basically, to look at these definitions and collect all these different p-hacking strategies. And then we first just collected them and then also decided to simulate each of these strategies and see what it does with the data and with the distribution of p-values, with the false positive results, etc. So this was how the paper started, and we already thought that all these strategies that people mention actually have a different effect on, for example, the rate of false positive results. And so this is what we also showed with the simulations and try to make accessible to other people by providing this Shiny app. And then since we saw a lot of variation in those p-hacking strategies, we also thought, well, let's at least think about how we could use this to also evaluate current methods that are out there for p-hacking detection and basically for dealing with p-hacking in the analysis of the literature, or also in preventing p-hacking.
Yeah, I mean, you mentioned quite a few things already that we could talk about later, especially I want to talk about the Shiny apps and all sorts of things that you mentioned. Maybe just first briefly, what exactly is your PhD about? Like, I know I've seen like you do a few like stats or meta science things, or have done them in the past. Is this kind of like a central part of it, or is it kind of a side project that grew out of hand, or is it, yeah?
Well, so I'm doing my PhD with the psychological methods unit at the University of Amsterdam, and my main supervisor is Eric-Jan Wagenmakers, who works a lot on Bayesian statistics. So the main focus of my PhD is actually on Bayesian statistics, specifically on experimental design and on prior specification in Bayesian statistics. So this is not exactly in line with what I usually do, but I think it still kind of fits in because it is still thinking about how we can improve methods that are used in, like, very broadly in psychology, and how we can obtain more trustworthy, stable, reliable, credible results. So I think it very, very broadly it fits in. At least that's what I'm going to try and argue for my my dissertation as well. But no, I think it still fits in. And
I was just curious whether you were, I don't know, whether all the other stuff you've been working on recently is also on that, or it's slightly different then. But maybe do you want to define p-hacking then, for, like how you define it in this paper, or you have to think about it?
We very broadly defined it as, and I looked it up actually in the paper, so this is a literal quote, as any measure that a researcher applies to render a previously non-significant p-value significant. So that's our broad definition, and then you get to the, for example, and all the strategies. So we try and have this one very broad definition and then go into the specifics with the strategies.
Yeah, and I guess that there's this one paragraph that kind of very early on that jumped out to me. I think that, if you don't mind, I'd actually just read briefly, because I think it kind of sets the scene quite well for that p-hacking is not just something people do intentionally because they're bad people, but that it's a bit more ubiquitous. So this is from page 4, you write, "It should be emphasized that not every researcher engaging in p-hacking is fully aware of its ramifications. There are many degrees of freedom in statistical analyses, and usually there is more than one right way through the proverbial garden of forking paths. This arbitrariness constitutes an ideal breeding ground for biases and motivated reasoning that can provide researchers with subjectively convincing arguments to justify their analytic choices in hindsight. Therefore, p-hacking is not necessarily an intentional attempt at gaming the system, but can also be a product of human fallibility." And it just seemed like that was an important thing to have in there early on, because I think
definitely, I think so too.
These papers can so often seem like it's like pointing fingers, saying like you're intentionally committing fraud and these kind of things.
Yeah.
Rather than, it's always interesting. Like now, especially when I go through those 12 strategies that you have in here, and often you go like, yeah, I've seen that often written in papers or something with some of these strategies, and some of them I think often seen as almost not exactly, but for example, like the sorry, now I keep forgetting how you call these strategies. The discretizing variables and variable transformation and that kind of stuff, to me always seems like stuff that a lot of people just do anyway, and I don't think they necessarily do it out of bad intentions. And then I'd like to discuss some of the strategies and kind of what the effects are. Maybe I'll just start by asking, like, what is there like any strategy that really surprised you here, the effects of it, where you thought like, oh, this is like a small, like, it's a strategy that can have an effect, but like it's probably not going to have that much of an effect. And then suddenly you saw the simulation results and you're like, oh wow, that's much more than I thought. This is a much bigger problem than I initially thought it was, or the other way around. Yeah, I'm just curious, like, did you have any surprises there when you did the simulations?
So I think one strategy where the results surprised not only me, but a lot of people, so also based on some responses I got on Twitter, was the variable transformation strategy. So basically just transform your variables, log transform, or take the inverse, take the square root, etc. And that this can have such big effects. I did not really expect that. Post hoc, again. I mean, I didn't pre-register my expectations. So post hoc, it seems sensible that using transformations on data that is normally distributed and then computing some regressions would create significant results just because you introduce a correlation structure. So I think you could even, someone told me in our lab meeting recently that you could even show this mathematically. I hadn't even thought about that, to be honest. So it seems like, yeah, this is something you could you could have known without the simulations, but that I was personally surprised about that the effects are this big. Something else I think I was also surprised about was outlier exclusion, that almost always has at least a decent effect. Even though we were very conservative in the way we implemented outlier exclusion, so we didn't just say exclude this one data point that makes the regression, the connection between the variables stronger, but we just excluded points that would be marked as outliers by popular outlier detection methods.
Yeah, I mean, you're right. Like, you didn't, I guess like the outlier exclusion that can often seem very bad is when you feel like people are kind of making up reasons for why they excluded this participant or that participant. But you didn't do that, right? You just had like generic
we just
exclusion.
Yes. And it was not perfectly, like, the data was drawn from a normal distribution, so we didn't have any skewed data.
Distribution, basically.
Yeah, in with some of these outlier detection methods. Yes.
Sorry,
Yeah.
Why? I'm just curious. I mean, this is kind of specific, random question, but why did you start with? So, if I understand correctly, you have the number of outlier detection methods, and you just start with 3, right? Like, that's the minimum you do in the figure. I guess like what I'm curious about is also like whether any specific outlier detection methods were particularly prone to doing this or something, just to like, increasing the false positive rate, or whether it was kind of more by stacking like several on top of each other that kind of led to this kind of effect. Do you see what I mean? Like, because I don't know whether I've seen many papers that use many different ones, or I don't know. I guess I don't pay that much close attention. No.
Well, I guess if someone did use this as a p-hacking strategy, you would only see one outlier detection method reported in the paper, and then the other ones would fall out. That wouldn't be reported. So what we did in the paper was we had, I think it was 12 outlier detection strategies, and we just made a random draw out of these. So we used 3 random outlier detection methods out of those 12. In the Shiny app, you can actually also try it out with single specific methods.
Let me see.
And I don't think I actually did this, so I would also be curious about the results. So I would think that the strategies that always find outliers are probably also the ones that can have the highest impact.
Right. You mean the ones that just
cut off percentages?
The most
essentially.
The most participants. Yeah.
Yeah.
Okay. Okay. I didn't see. I played around a bit with the Shiny apps, but not like all of it, and I didn't do that one. And I guess it's cool that you can just choose any combination or individual ones of those 12, and just kind of play around with it.
And with these simulations, I think this was also one of the reasons we wanted to have a Shiny app for people to play around with, because you always make these very subjective decisions on what simulations parameters do you use. So I think we just used 3 outlier detection methods as a minimum because we thought, well, that's probably what people would do if they do slight p-hacking. But a lot of this is just based on our subjective assumptions of what constitutes p-hacking, and also on our personal communications with people in our field, and also our subjective assessments of how much time people would be willing to spend on one p-hacking method, even if they intentionally p-hack using one of these p-hacking strategies, then how much time would they actually spend on using multiple outlier detection methods? How many do they even know? Something like that. But it is very subjective, which is also one reason for having the Shiny app.
Yeah, to put it negatively and specifically to one person, like the maximum, I guess, would be what Brian Wansink did, right? Just like trying as long until you basically find something, and then you go like, see, good science. I found a significant result.
It also, I guess, it always depends on your motivation, right? And how much time, how desperate are you?
There's also a trade-off, right? Like at some point, it just gets quicker to collect new data, more different data, right? Like at some point.
It also depends on how costly is your data collection procedure. Anyway, I mean, I think this would actually be an interesting topic, I think, for a meta science study, like for a survey on researchers who or people who identify as having engaged in p-hacking at some point in their career, and how much effort did they use on a certain method, a certain one strategy, or how many strategies that they use, what did they actually do. I would be interesting to see that, and I didn't really find any results.
Like, what's the most time-efficient way of p-hacking? It just really, takes you like 5 seconds, and you can definitely double your false positive rate. I mean, I guess you're explicit in the paper about this, that this is not a tool for p-hacking.
Yes.
And obviously on Twitter, half the people, it seems, made that specific joke that now they can...
I think literally everyone I've told about this project was like, I'm doing this project on p-hacking. Oh, so...
I wonder why.
I wonder why. So what exactly is your motivation? And what's the best strategy?
But what is the best strategy? I mean, to actually take this as a serious question. I mean, I guess we can frame this question once in terms of this like silly joke, and once in a maybe slightly more serious way, which is kind of what is the silly joke approach would be like, if I want to p-hack, what's the best way of getting away with something? Like, what's something that I can use that's kind of accepted in the field? It's maybe a bit difficult to detect from the results. It really increases the false positive rate. We can also phrase this question in the other way and say, like, when reading a paper, what should I pay particular attention to? Something that maybe signals someone is doing something slightly, or whether intentional or not, is doing something that might lead to an increase in the false positive rate. Do you see what I mean? Like, kind of what's the... Yeah, I guess just something when you see it in a paper that should really make you go, do I still trust this? Yeah.
For me, one of the most dangerous p-hacking strategies is optional stopping, because a lot of people who are not... I think a lot of people who are not following all the meta science debates and and didn't have like a lot of statistics education, don't really know that optional stopping, so stopping once your p-value is below a certain threshold, so stopping conditional on your p-value is actually...
You collect data and you continue to test kind of and then suddenly you get a significant result and you say, okay, done.
Yeah, exactly. And I think this is something a lot of people don't really realize is such a bad idea, but it is a really bad idea, because if you do this long enough, you're guaranteed to get a significant p-value. And it is something that you could, of course, if there was a pre-registration, you could probably see it. But if there's no pre-registration, it's very difficult to infer from a study, and everything can sound very, very, everything can look very good and reasonable, but then the results are still flawed and the error rates are up.
I guess there's also something that in many papers isn't just like, you don't necessarily always say why you collected this many participants or something, right? So if that isn't there, then you have no idea whether they looked at the data at all before or not, or anything like that.
Exactly. Whereas I think with, for example, dependent variables, even if there is no pre-registration, if someone focuses on a dependent variable that seems unintuitive, or is something that not a lot of people in the literature have done, then you may become suspicious.
Yeah, that makes... Yeah, I guess it's this kind of thing that's just independent of how strong the effect of it is. It's just something that's much harder to notice than the other stuff. Yeah, that's the one thing that, I guess, just surprised me in a way. I guess it shouldn't. Some things you mentioned earlier that, like, in hindsight, it's not that surprising in a way, but like that, the larger the sample size with optional stopping, the more you increase the likelihood of getting a false positive just because you have more opportunity for it to happen, basically, than if you only have 30 people. Yeah.
This is also something I think I found at least slightly surprising in general, how little large sample sizes are protective against p-hacking. And I would have wished it it would be better, because large sample sizes solve so many other problems, but for p-hacking, in many cases it just doesn't matter.
Yeah, I mean, that's also a point I wrote down and that I wanted to address. Like, I really thought that it would, just having large, I mean, you have large sample size, right? Like, we're not talking about, I guess for online studies, 300 people isn't that much, but if you run a lab-based study, testing 300 people can take quite a lot of time, right? So that's not for at least an individual study, that's not even the kind of sample size I would even really consider.
Yeah.
It's just, I guess the kind of studies we do are like, I don't know, 50 people or something like that. And then, we have a few studies, so then overall it gets a bit more. But I was surprised that even having such large samples of samples that basically you only really get if you do an online study or if you, I don't know, some sort of survey or something that gets sent out to lots and lots of people, you wouldn't even reach. And even then it just didn't really make much of a difference in most of the cases. But I guess you already kind of alluded to it. It's not, p-hacking is one aspect of good science. And, or I guess p-hacking is one side of bad science. But I guess you said like large sample sizes are good for lots of other things. It's just for p-hacking they don't do that much. I have to admit, like one thing that also really, I think I mentioned earlier, that really surprised me was just the kind of, variable transformation and I just don't know how to say it, discretizing, just making variables discrete. How that, making variables discrete didn't have a huge like upper limit in that sense, right? It kind of always seemed to be around like 12% false positive rates or something like that.
I think this also depends on how we implemented it. What we did was to use a median split, then like a cut the middle strategy, where we cut out the middle part and left over only a comparison between the most extreme groups. And then I think we had, of course, the continuous variable design. So we didn't have a lot of variations in there, like cutting it into 4 or 5 or 6 discrete groups. So this might be one of the reasons for why there's only so little variability. But I think this one was a really difficult one to implement in a simulation, because once you start, where do you stop? We decided to keep it minimal in that case and see what comes out.
Yeah, but I think it also makes sense, right? Because it seems to me that a median split is maybe not, I don't know whether it's still that common, but I've read a lot of papers that use that. And often in cases where you go, why did they use a median split? They could have, there was no reason to do this. They could have just analyzed the continuous data. Yeah. And
but again, it doesn't have to be malicious intent. It can be just you read it so often, then it's just an automated reaction to copy what you read in other papers.
Yeah, but I guess it is. I think I've always been fairly critical of that, because to me it always seemed like just. Sometimes sure there are reasons for doing it, but often not. And I think that's one of those strategies to me where I thought like it really increases the false positive rate, and it's something you see done quite a lot. So that's not good. Yeah. By the way, are there any? So you focus on these 12 strategies. 12 sounds like it's a suspiciously nice number, a good dozen. Did you have like a few more that just didn't seem that important that you didn't include because the paper was already long enough or something, or to make it kind of manageable?
We had a few things where we were on the fence whether it is p-hacking or not. So I think the last one that didn't make the cut was selecting effects from an ANOVA, for example. And then basically focusing your attention away from one main effect to the other main effect, or to an interaction effect.
Okay.
And basically at the last moment, we decided not to include it in this list because we felt that it was more harking than p-hacking, so hypothesizing after the results are known, and you would still probably see the whole ANOVA. So it is in a way, very transparent. So we felt that in a way it doesn't really fit in there, but it was really very close to making the cut.
Yeah. Yeah, I can see why you looked at it and why you didn't include it. Because then you kind of have to change the narrative of what you're doing, right? Because you kind of have to justify why you suddenly don't care about that.
Yeah. And this is exactly where we set the boundary between p-hacking and harking. So with, at least in our opinion, with the p-hacking strategies that we included in the paper, people wouldn't need to change the storyline, wouldn't need to change their hypotheses, whereas if you actually look at a different effect, you probably need to rewrite your whole introduction.
Yeah, exactly. And I guess you're not actually changing the p-value, right? You're just focusing on a different one.
Switching.
Yeah.
Switching focus.
Okay. Any other ones? Or I'm curious now. It's just also just interesting to see like the in a way, like I guess if I'm not a meta scientist, but I'm just interested in this from the perspective of trying to do well and like, not doing bad science. But it is kind of interesting. So like in a way, some of this is slightly like definition thing, right? Like, is it harking? Is it p-hacking? Like, from my perspective, it's like, well, it doesn't matter too much. But it is kind of interesting to see kind of what the boundaries are of these things and kind of.
Yeah, I think it's for us. It was also a learning process because people mention p-hacking, harking, and publication bias usually in one sentence, but still as different questionable research strategies. And for us, it really made us think about what are the differences, where is an overlap, where can p-hacking overlap with harking, p-hacking overlap with publication bias. Yeah, so this was also one little contribution we tried to make with this paper to just separate these concepts a little bit better. Yeah. Mm-hmm. As to other strategies that didn't make the cut, we try to be as inclusive as possible. So it's not like we have this big dumpster full of p-hacking strategies that didn't make the cut. That's not at all the case. We really try to keep everything in there that people at least repeatedly mentioned as a p-hacking strategy. One thing we didn't talk about in this paper was in several papers, it was mentioned that people would do self-selecting, sort of an individual publication bias. For example, selecting studies. I did 3 studies and 2 of them were significant and 1 got a non-significant result. And then I write up a paper and I write up only the significant results. And there are people who also call this p-hacking. In a way, it links in with the reporting strategies that we mentioned in the paper. So deciding what p-value to report if you calculated lots of p-values. But then again, all the analyses we did were using a single data set. So we didn't look at what if people collected multiple data sets and then report p-values out of multiple data sets.
I'm wondering like how much different that is from subgroup analyses. Because in some sense, couldn't you say if I remember correctly, your subgroup analysis basically say like we have this large sample of participants and now we split it up into different groups. Isn't that kind of like, I know, but you're still reporting all of them. Yeah, you're not like pretending one of them. Yeah, sorry, that's different. Yeah.
No, but it's definitely similar.
Yeah. So people shouldn't do that because I have a study where 1 isn't significant. The main thing. No.
Always be transparent. Always report.
It's very
everything.
Inconvenient.
No. No. Just I would always recommend transparency.
Yeah, the problem is we made the error of pre-registering it, so now we have to report it. Yeah, no, I actually like it because it forces you also to think more about what you're actually doing rather than just saying like, whatever, it didn't work. Yeah, I mean, maybe shall we just briefly talk about the solutions then? I mean, you already mentioned that large sample sizes aren't as much of a solution as we might have expected or at least hoped for.
Mm-hmm.
Maybe shall we start with one of my recent episodes was with Chris Chambers about register reports.
Mm-hmm.
So how do they kind of fit into this whole thing? Are they a solution for p-hacking specifically, or?
I'm a big fan of registered reports. I think they are great. If it was for me, almost every paper could be a registered report, at least if it reports confirmatory results. I think with p-hacking, it sort of has the same caveat as pre-registrations. Pre-registrations protect against p-hacking as much as they are able to limit your analytical flexibility. So I think what our analyses show is that you can basically use any p-hacking strategy. If you just use it aggressively enough, you will still get a very high probability of false positive results. And I think this is an issue for pre-registrations, because if we assume malicious intent and I just didn't pre-register something that allows me the flexibility to use one of these strategies, then I can still engage in p-hacking, even though I have a fairly compelling pre-registration. And I think this is an important message, or for me, it was an important learning, because it really means that when it comes to p-hacking, I won't necessarily assume that everything that is pre-registered can't be p-hacked. Not everything that is, not saying, I mean, probably most people who do pre-registrations and registered reports and stuff, I don't assume that they p-hack. That's usually not the same crowd.
It's not your first assumption, yeah.
But it's not as good at protecting against p-hacking as it maybe should be.
But it seems to me like a register report would then, if the peer reviewers do their jobs, actually be like a good, they can kind of safeguard that people actually specify, for example, with respect to these 12 strategies, what they're going to do to then actually limit the flexibility that you do have. So it seems to me, I mean, I completely agree with you. And I feel like over the last few years, I've also met some people who I think weren't as much in favor of the open science movement and kind of did some things because they kind of felt they had to go along with it. And then, I mean, I don't know, maybe they wrote great pre-registrations, but I feel like if you're kind of just going along with it because you feel pressure to do it, then you might not be as specific as maybe you should. And you kind of just say like, oh, we're going to do, just like a very vague pre-registration. But it seems to me like a register report could then actually, let's say the potential problem that you just addressed with p-hacking and register reports, you should be able to largely avoid, let's say, with having peer reviewers actually look at it and say, hey, what's the outlier exclusion criteria? Please say it.
Yes, I think that definitely makes sense, which is also why I think a registered report is even better than just a pre-registration. Also because it's so valuable to get feedback from reviewers and to still be able to change your study based on the reviewer feedback. And I think that's also just great. But also in terms of the pre-registration, I mean, it is also just so easy to forget something. And again, p-hacking doesn't have to happen with malicious intent. It can also just be hindsight bias. And I think it's great if reviewers look at all these aspects of analytical flexibility and try to improve the pre-registration together with the authors.
Yeah, in a way, it seems to me almost like you could use the 12 strategies you have here, not exactly as a checklist, but as something where you go, do I state specifically what all of the DVs I measure are? Do I, in the pre-registration or register report, say whether I'm going to do any transformations if X or Y happens or whatever, right? Like, in a way, you can almost use this to protect yourself from hindsight bias and these kind of things. Because I agree. Like it's so easy to just forget to specify something. But if you have like a list in front of you that says like, 12 things you shouldn't forget, then I guess the OSF already does that to some extent, right? They have like
there are pre-registration templates.
Exactly. Are all of these in there, or I didn't check?
So usually pre-registration templates are a little bit broader. So they would, for example, also ask you to specify the sample size and specify what your overall design is, what the stimuli are that you want to present, etc. So depending on what version you use and how extensive those pre-registrations are, they even have more aspects that we didn't explicitly mention. We didn't design. I agree that it is like it probably gives you a good idea of what to fix in a pre-registration, but like we didn't design this as a pre-registration template. So I think it's always better to use one of those pre-registration templates, specifically if you're working in a field where there's already a field-specific pre-registration template, because I think they thought of so many more things than we did when we actually were just thinking about what could people do when they p-hack. So I think I would use one of those.
Yeah, I agree definitely. It's just I guess more like in addition to that. Yeah, I guess as you said, like those. There are some templates that are super intentionally super vague or like very very minimal, right? The as predicted, whatever it is, where they just say like, what's your sample size, what's your DV or something like that.
But still, I think that is still much better than no pre-registration.
Yeah.
Because at least especially with as predicted, your pre-registration becomes public after a certain time. So you would know that there is a study that at least was planning on looking at this research question, which is already super valuable information for meta-analyses, for example, because then you could just email the authors and say, hey, where are your results?
So, yeah, exactly. Yeah, but I think as an additional thing,
yeah, definitely.
I wonder, maybe I'll try it just next time. Have your paper next to the computer, and
there's actually a really nice paper from Jelte Wichert and from 2016. It's called "Degrees of Freedom in Planning, Running, Analyzing, and Reporting Psychological Studies: A Checklist to Avoid p-hacking."
That sounds like a checklist. Yeah.
That has it just lists a lot of points of flexibility. So in comparison to our paper, it doesn't look very closely at each strategy. It doesn't do simulations, but it has this huge table somewhere in the middle that lists so many degrees of flexibility. And I think this is also a great basis for pre-registration, because you can basically just go along and say, okay, fix this, and basically set your check marks.
Okay, that sounds pretty good. I'll have a look at that then. And also, I guess for anyone who's listening who hasn't listened to this podcast before, I always put references to stuff we mention in the description, so you don't have to look for that. You can just go to the description of the episode, and I'll put it there. I'm wondering whether we should talk a little bit about about combining of p-hacking strategies. To some extent, it just seems to me like the more you do, the more likely you are to get a false positive. Yeah. In a way, it's like a very simple story, right?
Yeah, it is. Just the only thing you can really add is that the additional benefit is it's not exactly additional. So if you did the same two strategies with the same in the same intensity, then if you look at the effects of this strategy as on its own, then the combined effects are smaller than the sum of the single strategies.
So it's diminishing returns.
So yeah, diminishing returns.
The more you p-hack, the harder you have to work at it.
Yes.
Proportionally. I also like the term ambitious p-hacking. It makes it sound very good. It's like, oh, look at these people with their ambition. So they tried so hard. Yeah, I guess, sorry, we were briefly talking about solutions. I guess you were probably fairly happy that using Bayes factor, given the other part of your research, I guess you were fairly happy that Bayes factor seemed I mean, if I remember correctly, it seems like effect sizes and Bayes factors were actually some things that, especially in combination with large sample sizes, actually did help, right? Were you nervous when you ran that analysis? Or
A little bit. But it's clear that if you generate data under the null hypothesis, so with a null effect, then eventually the Bayes factor should just show evidence for the null. But of course, the question is, when does it do that? And to be fair, the analysis we did in the paper are also not super extensive. It was just one way of showing, okay, so a Bayes factor can help, but only if it's in combination with large sample sizes. So we didn't do a full scale, really big analysis because that would have been another paper. But I think when it comes to what can we do against p-hacking, I think looking more at effect sizes and Bayes factors already helps also, because it takes away the focus from those wretched p-values.
Yeah, and I guess like what you did is also more like pointers, right? And like certain different directions of things that people have tried and saying like, does it seem like this helps or not, rather than like fully answering that question. Yeah. Maybe a kind of last thing about the study itself, kind of, I'm curious, in the end you say, so the last sentence is, our compendium and simulation of p-hacking strategies can be viewed as a first step in this direction. I'm just curious, are you yourself doing more of those steps, or is that more something that you're leaving to Felix or other people? Or
I will first try and finish my my PhD thesis,
okay.
And then we'll talk again about that. But I think there are lots of interesting research questions coming out of this, and I mean, I already mentioned one, looking at what do people do if they p-hack, and basically just doing a survey, seeing what there's a lot we still need to understand about what actually happens out in the wild, basically. And we always make assumptions in simulation studies, and I think it is very important to check how valid these assumptions are and confront them with empirical data. So that's something I would be very interested in looking at. I also think there's a lot you can probably still do on with regard to p-hacking detection methods. So in the paper we said it is very difficult, and because you always have a mixture of effects, you have a mixture of p-hacking methods, etc. But I think that it would be interesting whether there's some possibility to also separate p-hacking from publication bias in the literature. So I think there is a lot you could do in that way as well.
What are some good strategies of detecting p-hacking in a single paper? I mean, I think you mentioned at some point that most of these strategies are more for like a field. Yeah. And you can say like, look, all these, collectively this field seems to be hacking away. But how can you detect p-hacking in a single paper?
Well, short answer, I think you can't. Unless, I mean, you can have, as you said, for example, it is very suspicious if someone uses 3 different outlier detection strategies throughout the paper. At least as a reviewer, I would ask why. Is there any specific reason apart from that your p value is significant now? I don't think, but I think these are mostly just gut feelings or suspicions, and I don't think there's any analytical method that can tell you based on a single paper this is probably p-hacked or not. I think I saw something at some point where people try to train a deep learning algorithm on papers that were p-hacked or not. I don't know how they knew in the first place, like what their training sample was. And then you could probably use that deep learning algorithm on the paper and get some probability of it being p-hacked. But then I'm not sure how good that works. So I wouldn't really trust this, to be honest. Yeah. But it's an interesting thought that people might reveal themselves by using certain language if they do p-hacking.
Yeah, I wouldn't trust that too much.
No, me neither. But I think I saw it somewhere. I don't know the reference though, so may have been a dream.
Maybe, I don't know. It's a very specific dream you have. Yeah, you're deep into your PhD in meta science if you
this happens.
That you dream of papers that don't exist. Yeah, I mean, I guess to some extent the whole problem with people doing bad science, I guess the difficult thing, it is really, really difficult to detect and to even prevent. As I said, like you often just forget stuff and then analyze things with a bit of. I mean, like the first study I did in my PhD, we're kind of finishing it now, and that's like basically for 2 years it's just been lying around, and so after 2 years suddenly you're like, I kind of thought I wrote everything down, and luckily we pre-registered because otherwise, God knows what I was thinking 3 years ago. Can we talk briefly about Shiny apps? Because
yeah, sure.
I've seen them around. Occasionally I've used them, but I've never actually made one myself. I think I might have looked into it briefly, but I'm just kind of curious, like how does one make a Shiny app? Kind of what's the process? Is it easy? Is it a year of your life you wish you had back? Well, what was it like?
So I think it depends on your R literacy. If you already use R for running analyses and doing other things, maybe writing R Markdown files, etc., then I think it's not such a big step. I made my first Shiny app during my master's, actually for my master thesis, and I think it took me around a day to figure out the basics. And there are very good tutorial videos from the Shiny RStudio people that I found extremely helpful back then. And basically, I just created the structure of this Shiny app and everything based on those tutorial videos, and then I tried to fill it with my own content. So with every Shiny app basically has two parts. One is the user interface, and then the second part is the server side. And so with the user interface part, you basically tell R or Shiny where all the boxes should be, what the panel should look like, where do you want to have a figure, do you want to have a slider or multiple choice menu, for example. Then with the server side, you fill this user interface with content. So if you say, I told Shiny I want to have a plot in my main menu, and then I fill it with information, with data or whatever.
Okay, so it sounds pretty easy from the way you described it. I mean, I guess, were you already familiar then with R when you started? Or
I did have some experience with R. Generally, making Shiny apps is easier than you would think. The only hurdles, in my experience, are that you sometimes have to deal with reactive values that are inherited from JavaScript. So basically, you have something like if someone pushes this button, then this reactive value changes to 1.
What's a reactive value?
So this is it's basically a value that is defined by what a user does, for example, button presses.
Right. Okay.
So sometimes it's sometimes a bit difficult to debug these reactive things because you can never really test all configurations, and sometimes the error messages are not very easy to understand. But then I usually just go on Google and Stack Overflow and look up what other people say, and so I think it's easier than most people think, and I think it's a great way to display information in an interactive manner.
Yeah, I mean, it always looks like it's, I don't know, it looks like it would be a lot of work when you see them, because it always seems like, I mean, I know that there are lots of tools for building websites and all these kind of things, and in principle it could be relatively straightforward, but often this thing isn't straightforward in practice. But that sounds good.
Yeah. So I mean, I can tell you, I actually looked at my app code So I have 2 code files, one for the server and one for the user interface. And my user interface code part is about 450 lines of code, and the server side is 380 lines of code. So it's
the question is, how efficient is your code?
That very much
For
depends.
some people, 450 lines can mean almost nothing. But to some,
maybe this revealed a lot about how efficient my code is.
But it doesn't sound like a lot, I guess.
So this is actually what I wanted to say. It sounds like, because I think the app looks fairly complex, but it also makes use of all these simulation functions that we already defined for the R package. So basically, what we do is just to say to create a user interface for those simulation functions. I feel like it looks more complicated than, well, roughly 900 lines of code.
Yeah, which is, again, I don't know. I mean, I also haven't done much in R, so I don't know exactly how that's. I've done a little bit in R, but okay. I guess if you say it's easier than one would think, then I'll just take that. That sounds good.
Yeah, I would really recommend looking at those RStudio tutorial videos because they are awesome. Maybe we can also link them.
I'll find some and put them in the description. Do you have to pay for this? I think I once looked into it and it seemed like you had to pay for it, for like hosting the thing or something like that. Or is it like through the university? Or
you only need to pay for it if you want to host more than I don't know how many apps on the Shiny app server. But you can. So we have the advantage that Felix has. Felix Schönbrot, my co-author, has basically his own server that is connected to the LMU system, so the university in Munich. So he is hosting the app on his own server, but you can also for free host apps up to a certain number of apps on the just with a user account on the Shiny app server, and you can always create as many apps as you want if you just use them on your own computer.
Right. Sorry, I just looked at the URL. It is shiny.psy.lmu.de/Felix.
Exactly.
Yeah. Yeah. Okay. I mean, I don't know whether I'll ever do anything that would really. It seems to me like these kind of apps are particularly useful if you have a kind of large data set with lots of options, where in a paper, just you, as you said earlier, you kind of have to make. If you put it in a paper, you have to make decisions and reduce the space of things you mention and talk about. So I think for those things, it makes a huge amount of sense. Not sure whether I actually have anything like that, but it's always nice to click around, kind of see what people did.
Yeah, I think it's also nice for teaching if you want to explain some concept and statistics or
like p-hacking.
Then it's nice also for students to have an app to play around with. And I think I get the impression that students really like it, and it hopefully fosters understanding.
Yeah, especially, I mean, I haven't. So you said you wrote an R package, or what did you call it?
So with this paper, we both created a Shiny app and an R package. So basically, you can go to GitHub and download the R package, and then you can use the R package for simulating p-hacking and redo some of our simulations.
But that's largely equivalent almost to the Shiny apps then?
It's largely equivalent, yeah. So the R package has a few more options, but it is.
I guess what I wanted to say is just like for teaching, it's pretty cool then that people, you can have like a quick click around, and then if you're really interested, people can like look a bit more into the code and how it actually works, and also learn like these kind of simulations with it or something like that.
Maybe at this point, I should also stress that the R package is only for simulations. It doesn't do p-hacking for you.
You have to do it yourself. Yeah. Although there's this big header that keeps looking at me, which is obvious warning, thou shalt not p-hack. So you can be very clear on that. Don't do it.